moving forward, this is the, you can say, the heart of patient data in OpenMRS. Now, why I'm saying so is because when it comes to patient data, for the most part, almost all data, apart from, you can say, patient demographics and allergies and conditions, stuff like that, apart from these, almost everything gets stored in encounter and observations. So these are the two most critical tables. Let me, give me a second. This, I think, something that needs updating in my presentation. Give me a minute, please. Sorry, this was paused. Now I'm going to go again. It's really critical. Alright, so talking about encounters, encounter table and obs table. This encounter and this one obs table. These are the two most critical tables as far as the patient data is concerned. So in your database, the whole OpenMRS database, if say your database is 5 gigabytes, you can safely assume that 4 gigabytes of them will be just encounter and observations. Why? Because encounter captures any event that happens between patient and any other healthcare professional or user or data provider. So basically, if a patient comes for screening, someone who's going to screen this patient, this event is going to be recorded as an encounter between patient and someone from the team. Similarly, if someone's doing the diagnosis, there's a TB specialist, a clinician, or a lab person, or even a nurse, or any receptionist, whoever this patient is encountering throughout the journey, the treatment journey, that each of those events are going to be recorded as an encounter. So you can think of encounter as in a paper-based form. If you are filling a form, that is like filling in an encounter. It can be viewed as a filled form. Now that's encounter. Encounter contains all the metadata about the encounter itself. Encounter table is not a metadata table. What I'm saying is that, say, when was this encounter occurred, between who, where was this occurred, which date, all of this data is going to be saved as encounter. Now every question within that encounter, an encounter is a collection of observations. Every question and answer pair is called an observation. So for example, if somebody asks for patient's weight in kilograms, so the question is weight, the answer, say, 58 kilograms. This combination, this pair of question and answer is called an observation. It records as one. And similarly, any question can be represented, any pair of question and answers can be represented as an obs. OpenMRS is quite flexible in that manner. So there's literally nothing that cannot be represented as encounter and observation. There are certain systems which are built around encounter obs only, not utilizing anything else. That is also possible, but then it makes your system overall very inefficient, because you're putting everything in these two tables, so it's going to become very beefy and respond slowly. Now about the observation table, obs table is hierarchical, meaning the data, first of all, no records are deleted. That's a given. That's throughout the OpenMRS database. But even for the records which are changing. So for example, you entered weight to be 58 kilograms and you made an error, it was actually 68. When you make that correction, when you enter a new value, what OpenMRS does is it adds a new record, a new row as a separate observation, and then makes the previous observation's ID as parent. So let me just quickly show you what it looks like in the open obs table. So let me open the observation table. Namespace missing. Wow, it appears that no worries, I can open another one. Okay, so you can see we have obs ID, person ID, all these columns, and then we have previous version, meaning version 1 was holding value 58, version 2 was holding value 68. So the row 68 will have reference to the previous one. So this is how obs table is formed in a hierarchy. You can also group observations together, and I'll come to this part in more detail as I explained. It's like understanding encounters and observations is like understanding half the OpenMRS. That's how significant these are. Now encounter table contains encounter type. Encounter type is literally like form 89 is an encounter type. There's an encounter type for MD, TB03, TB03U, all these forms. Every form you are filling has a name, and that name is represented by encounter type. Then we have encounter providers. Provider is the person who is providing the data. It appears as provider and user are the same thing, but in reality they are not. What do I mean by this? See, user is someone who is interacting with the OpenMRS system, entering the data, right? And provider is someone who is collecting the data originally. So in a paper-based system, there could be a separate person who is collecting the data on a paper, and a separate user who is entering that data on the OpenMRS EMR. Now in this particular case, these are two different people. However, in the fully digitized paperless system, you will have them as same person. So even in our program, provider and user, these are not two different people. The same users are also registered as providers in the system. So encounter provider is the person who is providing that data, that form data, which which is being entered. Now then there are more tables which have been recently which didn't exist previously. Encounter diagnosis, encounter role, notes. If you have certain notes, so in an encounter you may have 100 observations, but if you want to attach a particular note, pick up a particular observation as a note, then you may use this. The flow, the way it works is, say a patient enters into a facility. As the patient enters, you start a visit. So the person is visiting your health facility, a hospital. Now in a hospital, the first encounter happens at the reception. Goes to reception, tells, well, I'm here for XYZ symptoms. I have cough, I have night sweats. This is first encounter. Then the receptionist refers this patient to the chest ward, the pulmonary disease ward. This person goes to the chest ward, and then there's another TB specialist who attends him. That's encounter number 2. He collects all the data, all the information, all the symptoms, and then orders for chest x-ray and smear microscopy test. Now this person goes to lab now, the radiology department for chest x-ray, gets the chest x-ray performed. This is encounter number 3. Chest x-ray results are obtained. He goes to the smear, the microscopy lab, and submits his sputum sample. That's encounter number 4. So you see, in single visit you have multiple encounters. Then the next time this person leaves, the visit gets closed. Then the next time when he visits, another new visit is opened. In our system in Tajikistan, we are not using visits, and it's strange to me because those visits have been existing for a long time in OpenMRS, and yet we have not adopted visits. So the system is quite open into encounter and observations only. Encounters are not collected as a group within a visit. So what it's supposed to be like is, you have a group of visits for a patient, and against every visit there's a group of encounters, and in every encounter there's a group of observations. That's how it should go. But we don't have visits, we go straight to encounters and then observations. This is something I would very highly recommend to change as we progress, and immediately if we can, because collecting everything as visits basically simplifies a lot of development work, a lot of reporting work, makes it very easy to summarize patient data and generate reports, that sort of things. Anyway, what we have is visit types, and then we have plenty of tables for encounters, encounter type, provider, and role, and then there's an obs table. Let me show you the obs table once more, and here I would like you to look into and sort of appreciate the brilliance of OpenMRS's design team. See, we have observations against people, and then there's a concept ID. Concept ID is to define the question being asked in this observation, right? And then respective encounter ID, which encounter is this observation part of, the order ID if an order exists for it, location ID, where was this observation collected, observation group ID if multiple observations are part of same group. You can there are further fields. Accession number is not important. Have a look over here. Value group ID, value boolean, value coded name, value drug, value date time. These are separate columns to collect different observations with their types of observations based on their data type. So if you have a question against which the answer was in open text, then that answer goes over here in value text. If you are asking for height or weight or pulse rate, that data goes into numeric. If you are asking a question and the answer is a date, that date goes over here. And most importantly, if you are asking a question to which the answer is another concept, a closed set of options, then each of those options are going to be represented as codes in concept dictionary, and over here you record those codes. Now this table is heavily indexed by schema, so you can see all these keys. You have unique key, UUID, answer concept, which is value coded, value drug, encounter ID, all of these are indexed, which makes the table quite heavy on storage, but it makes it super searchable. So constructing queries for this table is also quite easy. Yeah, and then these are foreign key constraints, plenty of them, to several drugs. This is ops table is something which is most valuable, but also very sensitive, as in you can't make changes blindly into this table. It's not wise to make any changes at all. And by the way, even if you make any change, any update, any bulk operation, it may take even an hour to even complete that query. That's how many records this table holds. So which is why ops is something we take very very seriously when it comes to data. You should never tinker with the data directly in ops table. Having said that, sometimes it does become a necessity to fix data manually because of some bug or any miscommunication. In those cases, I would always recommend to have a test, always have a copy of this ops table somewhere, and first test your changes on reflect on the database, test your changes and make sure that you are not breaking anything, and then restore the from the backup if something goes amiss. And never do this in the live system directly. First implement in test instance and then move to the live one. That's something highly recommended. Alright, but having said that, OpenMRS does provide you ample tools and a good UI to even handle those fixes too, so nothing to worry about much. This is encounter observation, and you will be dealing plenty with these two tables as we move forward. So right now I'm going to next talk about something called workflow. Remember, I explained that patient data is scattered in many different divisions. So I did show you a few tables, but now we are going to talk about something that's called workflow, which manages patient data in a structured way, in a proper workflow following a business logic. Now have a look at this schema, workflow schema. You have patient program, we have patient state, you have workflow state, you have program workflow, you have program. What are these different tables representing? All of it is basically again metadata, but this metadata is driving the logic behind any program. So we have a DOTS program and we have an MDR-TP program, right? What happens is you define business logic about operational procedure of every program. So first of all, you are going to define a new program, create a program called, say, DOTS program, and that program will have one or more workflows. Say DOTS program has say 2 workflows. You can say DOTS program's first workflow is that you are reaching the patient in various locations geographically. Your healthcare workers are reaching the patients. That's one workflow. And the other workflow is when the patient is reaching you. A walk-in who comes to your facility is also following another workflow. So within the same DOTS program, you have 2 different workflows. They may have different rules, they may have different set of outcomes, different stages in the mid, but these are 2 workflows of the same program. Now every workflow, every program workflow has these states, meaning what could be what could be a set of states against any patient in one particular workflow. So for one workflow, you may say the patient might be a suspect, a confirmed TB case, and on treatment. That's it. For another workflow, you may say, well, a patient can be confirmed patient during treatment, on treatment, and then another state could be defaulted or lost to follow up. Another state could be treatment complete. Another state could be retreatment, or another state could be died if the patient died. So you may define different states that a patient can be in. So these are called patient states. Now patients will enroll in particular program, and within that program they will follow one workflow at a time. They can follow one workflow, complete it, and then they could be switched to another workflow and then complete it. And within this whole process, patient will be in one of the predefined states. Now this may sound like a complete jumbled up explanation. So I'm going to show you exactly what I mean by this. I'm going to go into manage programs. See, here we have two programs, MDR-TB program and DOTS program, right? These are the two programs against which a patient can be registered. MDR-TB program has 4 different workflows. So CAT4-TB, you have a hospitalization workflow, you have MDR-TB workflow outcome, and another CAT4-TB is also basically two different split into 2 different workflows. So according to previous treatment and according to previous drug use. In DOTS program, you also have 4 different ones. And by the way, one more thing, these workflows underwent a few changes, and what happens is that we cannot simply remove a workflow, because all the patient data, the logic, everything is defined against a workflow, and changing them means breaking the old historical data and even the reports. So I am going to show you what we define against one particular workflow. Let's say we pick DOTS classification according to previous drug use in DOTS program. Reload. What? Yeah. Now in this workflow of DOTS program, a patient can have 3 states. A patient can be a new case, a patient can be previously treated with first line drugs only, a patient can be treated with second line drugs only. You can add more states, but what you are saying is if the patient is registered within this workflow, the patient can be in one of these 3 states in this program. Now the flexibility this structure gives you is that you may have a TB program, an HIV program, another program for say measles, another program for child vaccination, irrespective of what the program is. Every program will have will be independently handling this single patient. That's the power this structure of workflows gives you in OpenMRS. See, that's the strength of OpenMRS. It lets you define your diagnosis, treatment, all healthcare business logics in a very dynamic way, which is why we are saying that the baseline, the core foundation OpenMRS is really strong. It can support almost any healthcare, any general purpose healthcare program. So that's how workflows are managed. And by the way, there's a word of caution. This is for our current program, this is like a no-go area right now. When are you going to make any change? So for example, you launch another program for XDR-TB, and let's say you're saying for XDR-TB there will be a different workflow. It will have a different registration number for patients, and that's how you are going to operate this. So you will create a new workflow for that program. Don't make any changes to the old workflows, because once a workflow is defined and you start entering patient data, that is pretty much fixed. Otherwise you'll have to make manual changes to the code as well as run manual queries to clean the data, and that's not something that's easy to do in OpenMRS. Unfortunately, data cleaning is not trivial inside OpenMRS. So that's, you can say, one of the weaker areas. Anyways, this is so far we've discussed mostly patient related data, their workflows, locations, users. Now we are going to jump into a unique entity called concept. Understanding concept is sometimes tricky initially, but as you work with concept dictionary, you get the idea, the complete picture. So concept table contains a dictionary. This is basically vocabulary of OpenMRS. Your entire system, all terminologies being used in your system are going to be part of concept dictionary, period. So nothing, any word, any term, any question, any answer, anything you have in the system will be reflected here in the concept dictionary. Every question in the system is a concept, every coded answer is a concept, every drug is a concept, every test is a concept, every diagnosis is a concept. For example, if you ask a patient's profession, the word, this term profession, you're asking for profession is a concept. And if the patient answers that is a minor, that answer minor, that minor word is, this term is also a concept. Similarly, weight is a concept. Its value is provided in numeric within certain acceptable range, but weight is a concept against which you are collecting numeric data. And then a group of concepts can also be a concept. For example, you are collecting vitals, you are collecting heartbeat, you are collecting systolic and diastolic blood pressure, you are say collecting pulse rate, oxygen percentage of, taking observation from oximeter, and you are saying all of these are vitals. So vital is going to be a concept, and this concept is going to be group of concepts, and each of those concepts is a vital you've collected. So a group of concept can also be a concept, meaning you can say it's like an atom in any object. So every object is made up of atoms. So concept works like just atoms. Now let me show you the schema of concept table, but give me just 2 minutes. Alright. So coming back to concepts, now you are noticing some tables here. There's a concept table, a concept data type, concept class, name, description, answer, concept set, and concept numeric. So what are these? Concept itself is the table which holds everything together. All of the rest of what you see are references. Now pick concept data type. Concept data type basically tells the data type of this particular concept. Is this numeric concept? Is this open text? Is this date? Is this boolean yes and no? What type of concept this is, right? And then we have concept classes. Concept classes are sort of gray area. Why do I say this? Let me actually show you so that you let me open these two tables. There's concept data type and then there's concept class. Now as you can see, in the data type, this is easy to understand. So data type is numeric, coded, text. NA is where the concept itself is just an answer. It doesn't have a data type, right? A concept which has a document in it, a PDF file, say a Word file, that has a type document. Then your date, time. The date is just absolute date. Time captures only the time. Date, time captures both. Boolean can be 1, 0. It can be yes, no. It can be true, false. It can be y, n. Anything which has two possible answers, that is called a Boolean data type. It can be a rule itself, right? Meaning this concept, the data against this concept is driven from data from another concept. It can also be a numeric which is structured. So for example, less than sign or greater than sign, or like you define page numbers when printing, page number 3 to 11. So those are structured numeric values. You can define that as well. And then there's further complex data type which can represent any object in Java itself. So you can say this concept is basically, its data type is location. Now location is the Java class within OpenMRS. So you can say a whole location is going to be stored in against this concept. That's also these are all data types. And then you have the HL7 standard variations, right? Now this is concept data type, easy to understand. But when it comes to concept classes, this is where that confusion comes. The one I said, gray area, because defining classes against any concept requires in-depth domain knowledge. For example, a concept can be a test, right? It can be a procedure, a clinical procedure. So if you have a surgery, say open heart surgery, if that's a term in your system, its class is going to be procedure. Now a concept can be a drug as well. This class is drug, easy, its a class is drug. It can be diagnosis, it can be finding. Now what's the difference between these two, and then how is this different from anatomy? That's where people can get things confused. So you might classify one concept as diagnosis, someone else might classify that same one as finding, another one might classify the same concept as anatomy. Now question itself is a class which is basically selected when you don't even know the right class. Similarly, we have lab set, we have medication set, we have convenience set. These are used when representing a concept that is a collection of other concepts. It's a group that is grouping other concepts. So if there's a concept, say smear microscopy, that concept is lab set. Its class is going to be lab set. Why? Because against that concept you will be collecting data related to smear microscopy. in multiple concepts, multiple observations. Similarly, for medication, if you are prescribing a whole regimen, you will name a regimen, create a concept, and set the class to med set. Convenience could be any other convenient set, meaning, for example, let's say profession. So you can have many professions. Actually, let me see if I can pull an example of such. It would be great to have. Yeah. So profession is, see, again, whoever set this class, it's identified as a question, as a general question, right? So the possible answers of worker, government servant, disabled, unemployed, pensioner, school child, housewife. These are all possible answers. Say I pick one, school child. Now this school child has no data type because it is only an answer. It cannot be used as a question itself, and its class is miscellaneous. Obviously its class is going to be miscellaneous because this is not a question itself. This is the end, the end of the hierarchy kind of question. Now if I go into, say, smear, let me see if I can find smear result. Is not going to be, yeah, smear result. This is a test. This class is test. Let me check another smear construct or smear method. Yeah, smear construct is a lab set, meaning against this concept you have a smear result, you have a sample source, you have a result date, you have a start date, you have microscopy method performed. These also are different concepts, but collectively they form a single set, which is a lab set. Yeah, so coming back, there could be symptom, there could be a symptom or a finding, specimen, program, miscellaneous, state. These are several classes of concepts, and this is where I would recommend you, whenever defining class of a concept, contact the OpenMRC's own team or refer to other concept dictionaries to understand how other people perceive the same term as which you are dealing with. And I'm going to show you the concept dictionary in a while. But this is basically about the concepts, and now expanding on this same thing. Concept is not only internal to one OpenMRS deployment. You see, there is something called concept reference. You have concept reference, source, and then term, and then map against any concept. What is this? See, this whole concept dictionary, collection of all concepts, is your dictionary. Meaning, if you are calling something, say, smear result positive, that's your definition to define anything in your system. So that's a term for your own program, smear result positive. Someone else, some other program might call it something else. They might call the same thing as MTB positive. It's a different word, but both terms represent the same concept, the same logical concept. So we have internationally these so-called concept dictionaries like SNOMED, and we also have SNOMED is short for systematized nomenclature for medical clinical terms, right? This is SNOMED. Then we have ICD-10. This is International Classification of Diseases, 10th revision. There's also ICD-11 and I think ICD-12 also exists. But this was 10th revision of International Classification of Diseases. We also have CEIL, which is Columbia International E-Health Lab, where Andrew Cantor works. I'll briefly talk about this guy. So basically there are certain international dictionaries holding large collection of concepts in the healthcare domain. So what concept mapping is the method of mapping your terms with other dictionaries. Meaning, what I am calling positive is represented as the plus sign V and E, plus VE. That's what I am calling positive. In SNOMED, the word positive is called POSITIVE, positive. So I'm going to map these two terms together. In my system, I'll define, okay, what I'm saying positive means exactly as positive in SNOMED dictionary. That's literally what reference mapping is. And you can also define the map type, meaning are these two terms exactly the same, or is my term broader than the other one or narrower than the other one. These are different map types you can define. Let me go ahead now and show you one mapping here. So see, there's a mapping. This mapping says in this dictionary this code 69 is exactly same as 69 of this dictionary, which basically you might get confused. What does that mean? It's the same thing. Yes, it's the same thing. What I'm saying is my concept over here is mapping to the same concept as this dictionary that I've defined. Now there are multiple dictionaries within this same system. Let me show you. We have so far installed concept sources. Yes, there are 4 different dictionaries in the system actually. There's a PIH dictionary where everything basically began, and then down the road PH Haiti installation was also adopted, and then we created an ETB Tajikistan dictionary. This was created by Ali Habib, which was the basically the person who created this module the first time for Tajikistan. And right now we are on this one, org.openms.module.mdrtb. Now I am thinking of removing this entirely and go back to ETB Tajikistan. But in thinking so, I was thinking, why not actually adopt an international dictionary altogether? But that's obviously a big decision to make. We can gather and then make that decision. If this module has to grow and add more components or more programs, we may actually consider seriously moving to an international dictionary rather than defining our own one. But having said that, there are certain dictionaries that are installed, and we can also add our furthermore sources over here. What this looks like, let me show you in the Excel sheet. Let me maximize this a bit. This is an Excel sheet holding all our concepts we are using in this system. Instead of entering them one by one, handling like that, I've just created an Excel sheet, and this is where we are managing all of them. But the point to note here is these are concept sources, ETV Tajikistan, MDR TV, High TPIH, and this is the map. This is the map. It's telling which source is mapping with which concept in the dictionary. So as you can see, the concept in PIH dictionary with an ID 5622, that is the same as our concept called other non-coded, the concept ID 35. So in our database, the ID 35 is same as the concept ID 5622 in the PIH's concept dictionary. This is not something to be expected to be understood in a single go. Of course, it requires some exploration, and for that I would recommend you to visit this website. It's app.openconceptlab. Yeah. Open Concept Lab is a club of all famous concept dictionaries, basically. If I go ahead and tell you the sources, so for example, the word, let's pick something from over here. Let's pick moderately positive. Let's see if someone else has this. Okay, so now you can see in PIH this concept exists, moderately positive, right? Its ID is 1408. In CEIL dictionary, it's the same concept is represented as ID 1363. In Lowing dictionary, the ID is LA 139396. So these are different sources to represent the same concept. However, you will see that some of them are moderately positive, data type is text. Most of them are Boolean. Ours is also, by the way, Boolean, if I'm not wrong. Yeah, it's basically positive yes or no. This is a Boolean type, and most of them are Boolean. But in some dictionaries, this is also. So, for example, in NMRS, this is recorded as an AND, NA type. So this is actually an answer to another question. Let's go ahead and search for the same in our dictionary. What does this mean? Represented our concept dictionary. See, this is our data type is NA, because moderately positive is an answer to these questions: tuberculosis smear result, tuberculosis culture result. It's an answer to these two questions. So its data type is NA. But if you're asking a question, is this moderately positive, and the answer is yes, no, its data type is going to be Boolean. That's why it is an extremely difficult and lengthy and cumbersome task for an entire healthcare system to adopt a concept dictionary. It's a one-time effort. If you make that one-time effort, it's basically peace for life. But to make that one-time effort, it requires significant amount of time and energy, which is why the smaller systems, basically with shorter scope, start with their own dictionaries and then progress towards adopting a standard dictionary. We have not yet moved through any dictionary, and if we did, I would be recommending CEIL dictionaries. This is Columbia International Health and Labs dictionary. So SEAL's dictionary is created, maintained by this guy, Dr. Andrew Cantor. I've met him in an OpenMRS conference. Let me show you his blog post, and this is a consider this as a must read, please. It's a very short blog post, right? In which he's explaining what the SEAL dictionary is, and it will basically tell why this is a very good dictionary to adopt, SEAL dictionary. And also Andrew Cantor is quite active in the OpenMS community as well. So if you run into any trouble, he is going to be always there to help you out. Anyway, coming back, I don't want to spend yet more time on this, although it requires further exploration. The whole concept of concept dictionary is much wider than what I've explained, but it's going to be more clear as we move forward, as we go to development and see actually how the data is being captured and stored. Now I've just shown you the ETP's concept dictionary, our own concept dictionary. It's an Excel file, concept mapping.xlsx. When the ETL process runs, this concept is picked, all the concepts are picked and then loaded into their respective tables. Right? So it's all manual SQL queries which are running in the background, but that's the best way to go when it comes to concept dictionary. You have an option, by the way, to let me tell you how you can download a custom concept dictionary. If it doesn't give it, I have it on my Dropbox too, by the way. You can subscribe to the Dropbox folder of SEAL, but you can literally download a dictionary, run the SQL, and it will replace all your concept dictionary terminologies. And of course that's not what we are going to be doing immediately. That's just one way of telling you how to. You can get access by writing to andrew.cantor@columbia.edu, and he's going to provide you the latest copy of the concept dictionary if you want it, or basically I do have it. It's just a matter of preferences and independency. Now so we have concept mappings. I also need to tell you about these two sheets. So concept name this is where the first mention of our translations arrive. Now concept table, as I showed you here, you can see the concept is expressed as a concept name table and concept description table. Well, what happens is that one single concept may have multiple descriptions. You can have a look over here. The word unknown, it's a translation. The Russian translation is this. The Tajik translation is this. But if you're talking about the word positive, right? Positive is represented in a short form as well as a full form. So the full form is called this, moderately positive. Its type is fully specified. But for the same, we also have two pluses and the type is short.
Always regarding the translations, we have Firuza who have no access to the system. I mean, to the concept part. So, is it possible if we share this concept translations into, for example, Google Drive and share the link for her so she can check and put the correct translations because the Russian and Tajik versions are not correct. There are a lot of mistakes in the translations, so we have to find some solution to fix that.
Okay, I have already, by the way, fixed this because earlier in the previous wave we had this, like, it was a it was really a headache to deal with translations. What we are going to do now is use GitHub. So because this is part of the ETL code, it's committed on Git. If you have to make any changes or translations, just change the translations, make a new commit, upload on GitHub. That's the way to go. So when we have this on GitHub, of course, from that point onwards, we have Dockerized deployments, and if there are any changes detected, we can redeploy and re-import the concept dictionary. That will be the faster way, because if we make any change to the database itself, through the OpenMIS interface, whenever the next time ETL process runs, it will override all the changes. So not really the best way to go. So as for the concept translations, that's the way to go. And also I'm going to briefly talk about the other translations. For those as well, we will be using GitHub, because that seems to be the only possibility. Because what's happening is some developer is going to be adding some translation, Firoza is going to be adding some translation, I'll be adding some translations, new concepts, adding new concepts, changing concepts. How are we going to manage these among ourselves? So for that I have basically decided we are going to use GitHub, and it's fairly simple. You can use it on the web as well. Just open the web, and yes, what we can do is, instead of having it as an Excel file, what we can do is have it as like a CSV. That is something we can do.
Okay, it means that we have to give Firuza access to that file so she can put the changes, and then she have to pull and push to the GitHub, or
No, she
is it
can give it to a
possible?
developer.
Yeah, I mean she can just enter the translations online.
So okay, this is an Excel sheet. Say I email this to Firoza,
Yeah.
and she makes a bunch of changes. She emails me
Yeah.
back. What I'm going to do is, I won't go into OpenMRS and make those changes. I will simply commit this new file, replace the existing file with this new one, commit the code, and rerun the ETL process.
Yeah. Okay.
It will take care of the concept translations.
Okay.
And
Okay.
also, by the way, I think I will have, once we have support for. I'm actually. I'm another guy who is very likely to start from August, the first August, and once I have him, I will have some time to work on these channels, because I fully plan to create single form on the web application to enter all kinds of translations, be it in concepts, be it in forms, be it in labels, be it in message properties files, so that we have one-stop shop for all the translations to deal with.
Yeah, it would be great.
That would obviously be great, but this is something.
Yeah.
How well this goes. So yeah, coming back, we have concept names, and then concept sets. Concept sets are again the same thing, set of concepts, but you will notice one field here, it's called sort weight. Sort weight tells you in a list of concepts in one set where this concept is going to come. So you see you have 0, 1 and 2. First one which will be loaded on UI is this concept. This will come on second place and this will come on third place. So the UI, the order matters. This is where you define the order. Similarly, this is one single set, right? It contains 22, 23, all the 22, 28. But there is an ordering. The first one which will be populated is this one, then this one, then this one, then third, fourth, fifth and sixth. That's how we define the ordering of concepts in concept set. You don't have to make many changes, by the way, in this entire thing. I'm just explaining the way it is in the in our concept dictionary. So this is our concept dictionary, and if it sounds like overwhelming, if you find yourself overwhelmed, then if it makes you feel better, everybody goes through the same process. See, creating a concept dictionary and maturing it, being able to publish it, that's a lot of work, and it takes years for some programs to do this. The point is, it solves your future problems. You have to do it once, and it's done for your for your entire program for life. So in some places the same is done for like on provincial level. Somewhere it's a particular healthcare groups. On some scales it's on national level. So it depends on basically how wide your scope is. Now, moving on from this, from concepts, we will keep revisiting concepts, by the way. Next on our list is properties. So properties is basically settings, custom values, custom defaults which you provide OpenMRS to work with. So for example, our default language is Russian, right? So there will be a global property with a key and a value. So every property is basically a key value pair, and a property table, global property table, has a property key, its value, a description, and an UUID. These properties are loaded at fetched at the runtime, during the runtime. Meaning, if you are changing any setting, you don't need to rebuild the code, or you don't need to restart OpenMRS. It will be applied as the user logs in again. That's a beauty of OpenMRS's properties management. Now, there are two types of global properties. One is related to OpenMRS core, and then you have properties for modules. If you have a core property, it will not have any prefix. If there is a property related to some module, it will have a prefix with the module ID in it, right? Let me show you how these properties look. You'll go to administration, and here you have this advanced settings. See, you can go to settings first, and all of these settings, all of these customizations, these are all global properties. So I have written default local to be EN. You can write RU, and the next time I log in, the default language will be Russian for every user, not only for me, for everyone. Min search characters, meaning how many characters should user enter before the search query actually executes. So if I go into, say, find patient, and if I'm writing only A, nothing's gonna happen. Now AL, now you can see the search starts happening, because minimum characters required to invoke search is 2. right? The name of the folder where the modules are stored, that's modules. Now you have address hierarchy. This is a module. These are 5 different properties of this particular module. You have concepts. There are a bunch of changes. So concepts are locked or not. If you lock them, meaning no changes can occur to concepts. You can go to dashboard, you can go to encounter types, form types. So for example, dashboard, encounter maximum numbers to show on dashboard, on patient dashboard. 3 encounters, 3 most latest encounters will be shown, right? Similarly, header show concept. These are concepts to be shown in the header. So 5497 is a concept which basically shows up in the header. Let me check which concept it represents. There is no such concept. So for example, if I say weight, right? Weight is 168. If I go ahead and write 168 here, save it, and then if I search for particular patient, Ali, you can see weight, height. This should appear over here in the header because I've defined weight. Now there's no value, that's another thing. So similarly, we have regimen, BMI. Some of these properties are defined. So what exactly is it do you want to see? Regimen display frequencies, regimen display. All of these properties have particular meanings, and in order to change any of them, you have to go through their respective documentation. Otherwise, there's a chance you may even break the system partially. So identifier types, patient search, and if you want to see them all in a single glance, you go to advanced settings. In advanced settings, you will see each and every property of the entire system. These are all global properties. So for example, right now, when you make a REST call, maximum number of results that are returned are 1000, and that's a big number, by the way. 1000 records can be returned at a time. If you see, well, the system is being slowed down because of this, you can reduce it to 100, 500, right? Similarly, you have allowed failed login attempts. So if you enter wrong password 7 times, the OpenMI is going to lock your account. But if you want to tighten the security, you may change it to 3, right? So every property you see here has a context in the system, and which is why there should be only one user, one super admin user with the authority to change any global property, because it requires serious understanding of the question of the system overall. Even I haven't gone through the whole list all these years. So some properties I don't know what they do. Anyway, this is about the properties, and now we are going to come to another strange yet very powerful feature of OpenMI, that is called message.properties files. These are flat files, and they are bundled for UI rendering. So they are basically inside the Java code, and what happens is there's a default messages.properties file. It contains all the in English translations, again in key value pair. On left hand side you have a key, right hand side you have a translation. If you have translations for a particular language, you will have their local written like this. So messages dot properties, then there's message underscore ru dot properties, then message dot underscore tj dot properties. Now let me show you. I'll go into the module code itself to explain what this represents actually. Resources, yeah. So you see, this is messages dot properties. I don't know why. Yeah. In our MDR-DB module, wherever we say MDR-DB dot add follow-up visit, this means OpenMI is going to look into this file and put this text over there, right? But if my user has chosen Russian as his language, then the same key is going to look into this file here. Okay, this one doesn't exist. Let's pick another one. Let's say we have sorry, I opened the wrong one. I need to open this one, Russian. Yeah, now this is the Russian translation of the same thing. This translation is not in the concepts, by the way. This is going to be populated only in the UI. This has to be referred as such because it's not in the database. It's in the it's in flat files. So you have a file for Russian, you have a file for English, you have a file for Tajik. For every language you are supporting, you will have a similar file, and these are basically for every term you will have a different translation. Now, why the pros and cons? This is easy to make changes to if you are using ChatGPT. You just provide a file, ask it to just generate all the translations, and then make changes to wherever you want to, wherever you feel like they are not accurate. That's the beauty of it. But then there's also a caveat. These files, since they are flat files, the problem we run into is this: there's no database that's containing these translations. So what you will have to do is, if you make any change to the module file, exactly the same change has to be made into the web projects file. So the same file must have two identical copies on the modules code as well as on the web. I will see if this can be resolved using this new module called database messages module. If we can deploy this module and this module resolves our problem of message.properties handling these, it will be great, because we will then be handling all the translations from the database and not flat files. And that's actually very important for our stuff, because there are now 3 languages to work with: English, Russian and Tajik, and it will be very cumbersome to keep updating the, because one more thing, this message.properties file, if you make any change to it, you will have to restart the server. If you make changes into the module, you have to redeploy the module. That's one of the pain points of using these files. So although it is super fast, much faster than any database. The drawback is bigger than its benefit now. So if our form is loaded in say 2 seconds, and if we move to database, it may take 2 seconds plus 200 more milliseconds. So that's the caveat, but I think it's now essential that we migrate to this structure, message or properties, the message database. I haven't yet explored the module itself, database messages. As soon as I find any time, this is the second problem I'll be resolving, which is going to help manage the translations way better than they are being managed right now. You see, we can't create concepts against each and everything. Say you just have a translation, let's say an error message. Let's say just there's an error message, this one translated from MTB plus other agencies. You're not going to create a new concept just to show this on your UI, which is why concept dictionary has to be considered exclusive to all the program terminologies, and for everything else you may be using this message.properties files. Anyway, plenty about this. These are two different things to look into: global properties and messages.properties. These are defining OpenMRS's settings in two different ways. Now you can say this is where our primary OpenMRS's context is concluded.